Okay, here come the answers to Unit 1 free response question B. First thing I want you to notice is that this is not a typical AP question because it was only worth 7 points. 2 points for part A, 3 points for part B, and 2 points for part C. The first question asked you to find the limit as t approaches infinity to explain the limit in the context of the problem. Most people did okay with this. We just need to do a little bit of fine tuning. The answer has 2 steps. The first, you must show the limit notation, and you should get 30. When you take the exponent and make it very large, the negative in front of it causes it to be 0, which means you're left with 600 divided by 20. The second part we need to improve a little bit. You had to include a time component because you're taking the limit as t approaches infinity, so you're saying as time increases, and then this word here, approaches, is the best word to use. Some people said the maximum is 30. Some people talked about carrying capacity. The maximum isn't 30. I'm not quite sure that this function is ever going to hit 30. And so talking about carrying capacity was fine. You just did a little bit more work than you needed to because you didn't have to convert this into a logistic equation. You could analyze this without having to divide everything by 20 to put it in the logistic form. Putting logistic form isn't wrong. It's just you're kind of wasting some time. Part B asked you to figure out whether or not the function was continuous at t equals 12. There are 3 parts to a continuous. There's a left-handed limit, a right-handed limit, and then a function value. And you had to include all 3 to get the 3 points. So here you're analyzing the left-hand limit. On the left-hand side, which is up here at f of t, because t equals 12, you were told that f of 12 is 20, so the left-hand limit is 20. The right-hand limit comes from this part of the piecewise. You had to analyze that, plug in 12 for t, and you wind up with 10 in the denominator, added to the 20 produces 20. And then the function value they told was also 20. The function value for y means f of 12, because right here the y function is the same as the f function, but only at this interval here. So that function value is 20. You had to incorporate all 3, and yes, you did that function value right here for f, but you had to include all 3. Finally, you say yes, it's continuous because the limit as t approaches 12, both coming from the left and the right, matches the function value of 20. The final part C tells you that the function is continuous at 10 and wants to know if there's a place where the y value or the output is 18. This part here, continuous at 10, is important because with 3 different branches in your piecewise, at 10, when you transition from the first part to the second part, is continuous. In the previous question, we proved that it was continuous at 12. So now by being continuous at the first, second, and third, and at the transition points at 10 and 12, you have y being continuous everywhere from 0 to 12. That's important because now, from 0 to 12 in a continuous function, you can use the intermediate value theorem to figure out whether or not an output of 18 is possible. The intermediate value theorem says plug in 0 at the start, you'll get a value. Plug in 12 at the end, you'll get a value. So let's find those 2 values. 0 produces an output of 10. 12 produces an output of 20. Because the 2 outputs are 10 and 20, and because the function was continuous between inputs of 0 and 12, the intermediate value theorem says 18 is certainly possible. And again, that was worth 2 points. Okay, I hope all those made sense. Since you made it this far, a polar plot that you can look at, you're welcome.